Hello everyone, and this is my reflection video about why chip making is so hard. Okay. Today I want to take you through a reflection on the chip industry through a field that might seem distant but actually powers nearly every device depend on daily. From phones to laptops and to cars, this industry's story begins in 1965 with a simple observation by engineer Gordon Moore, which now we call Moore's Law. He noticed that the number of transistors on a chip was doubling roughly every 2 years. This exponential growth laid the foundation for incredible advancements in technologies, transforming chips from simple circuits into the complex processors we rely on today. As I have realized or reflected in this journey, I saw that it's not just about technology, but also about the creativity, the competition, and even global power struggles shaping this field. So let's look at the key stages in chip development and what they revealed about our world today. And this is the chips of chip. This is the stages of chip development. Number one is the instructions set architecture or the ISA. The first step in creating a chip is defining its instruction set architecture or the ISA. This is like a blueprint for a processor. It set it sets the basic instructions the chip can perform. Standards like times 86 and the ARM are well known as ISAs that keep our devices compatible across different systems. For instance, like Intel and AMD have long dominated the x86 or the 86, which powers most computers, while ARM, found in many smartphones, and has recently gained attention. This is especially true with Nvidia's attempt to acquire ARM, sparking debates on whether one company having control over ARM could create competition issues. And knowing this, I realized that standards like ARM and x86 bring essential stability to our tech ecosystem. But when few companies control the standards, it affects also the competition and the innovation. It's a reminder that while setting standards helps technology work together, it also means we rely on certain companies to keep those standards fair. And the next one is the chip design. So once the ISA is defined, the chip design process begins. This stage is where companies bring their ideas to life by creating layouts and circuits for the chip. These days, many big tech firms like Apple, Google, and Microsoft have started designing their own chips instead of buying new generic ones. Apple's M1 chip, for example, was specifically designed for its own devices, making them faster and more efficient. But while these companies handle this design, they don't do the manufacturing themselves. They outsource this to specialized companies known as fabs. This shifts towards custom chip design shows how companies want control over their products, performance, and experience. Reflecting on this, I see it as a drive independence in tech. But there's also a risk. By relying heavily on external manufacturers, these companies are vulnerable to issues like chip shortages, which can disrupt their entire business. And it's a reminder of the balance between customization and stability. Next is the fabrication. So the next step is, or the next stage is fabrication, one of the most complex parts of the chip production. This is where companies like Taiwan Semiconductor Manufacturing Company or TSMC come in. TSMC is the largest chip manufacturer, producing for many of the world's tech giants. They operate on a huge scale, which lets them produce high quality chips efficiently. Even Intel, a long-standing player in chip design, is considering outsourcing some of its manufacturing to TSMC because of the high cost involvement. Realizing and knowing that the TSMC roles, I see both strength and vulnerability. It's impressive how one company can supply so many, but this concentration also creates a single point of dependency for the industry. A crisis at TSMC could impact global tech production, highlighting the importance of having a more diversified supply chain, especially in industries as crucial as this. And next is the equipment and software. And this is an initial or an essential step in chip fabrication is lithography, where patterns are printed onto chips. This process uses specialized machines, specifically extreme ultraviolet or EUV lithography, provided almost exclusively by one company, ASML from the Netherlands. And these machines are incredibly complex and expensive, and ASML is currently the only provider at the high end of this technology. This kind of monopoly is both a marvel and a concern. ASML machine are pushing the boundaries of chip miniaturization, allowing chips to perform better with less space. But if ASML faces production issues or uh, or decides to limit supply, it could severely impact the industry. This reliance on a single provider shows the trade off in high tech innovation progress and sometimes create monopolies because very few companies can afford the cutting edge tech required. Okay. And next part is the packaging and testing. Okay. About this is once chips are fabricated, they go through packaging and testing to ensure they work as expected. This is one of the few stages in chip production that isn't dominated by a few large companies, as many smaller firms handle these final steps. And this have a reflection. I have a reflection about this about a different side of the industry, one where multiple players, including smaller companies, contribute to the process. And it's a reminder that even in highly competitive fields, There are spaces where collaboration and in distribution of work still thrive. This diversity helps bring resilience and flexibility to the supply chain. and the, and the economic and political implication. The chips industry's reliance on a few big players has major economic and political implication. For instance, the US is a leader in chip design, but much of the manufacturing is concentrated in Asia, especially Taiwan and South Korea. Meanwhile, in China and in Europe are investing heavily to develop their own chip industries. This dynamic has led to a situation where microchips aren't just about technology, they are also about national securities and global influences. And to sum up all of my reflection, the chip industry has evolved from more simple observation into a global powerhouse, influencing everything from economics to politics. We've seen incredible strides in chip design, where companies are developing highly customized processors. But we've also seen that certain parts of the industries like fabrication and lithography are dominated by just a few players. This mixed innovation and concentration brings both opportunities and challenges. And ultimately, the story of microchips from design to production to geopolitical significance reminds us of the balance we need between innovation and accountability, as well continue advancing technology, and we must also be mindful of the ethical, environmental, and social challenges that come out with it. And that's all. Thank you.